For our next exercise, we'll create a lot plan using polar coordinate entry. Okay, so in continuation from our previous exercise using absolute and relative coordinates, this time we'll be using polar coordinates. So we'll be doing this lot plan in our exercise. So I already typed the coordinates for us, the bearing, the distance, and the line. Okay, and basically these are the items that you will see on lot descriptions. So we have a distance, we have the bearing. So let's start again AutoCAD. Let's start a new one. So AutoCAD ISO, the PWT. I have temporarily made my AutoCAD window smaller so that you could see the value entries that we shall be using when we input our polar coordinates. So I'll clean screen first. So as a review, let's recall our previous coordinates, an absolute coordinate value and the relative coordinates. Okay, so let's invoke AutoCAD to do a line command. So L, then enter. For our first point, let's input an absolute coordinate. So let's type 10, 10, enter. Then let's zoom in towards that particular point. And as we have previously discussed in our previous videos, our grid lines are actually in 10 increments. So the first point of the line rests at the intersection of our grid lines. So from 10x and 10y. And for relative coordinate, we usually precede the number with at. But since we are using the dynamic input, there's no need. But for purposes of illustration, let's just use at, okay? To denote that our next coordinate will be in reference from the last point. So whenever we use the symbol at, we command AutoCAD that our next point shall be from the last point or from the previous point, which is the 1010. So in essence, when we type at, we prompt AutoCAD or we command AutoCAD that from the last point, we move, this for example, 400x, comma, then 400y, enter. And then zoom out to see the extent of our line. So escape, and we have created a line, a diagonal line using first point absolute and second point relative coordinates. Now we have a new type of coordinate which is related to relative coordinate, this time with polar. Okay, so relative polar coordinate, this time instead of two coordinates, it has one value and then the other value is in angle, okay, or degrees or other measurement for angles. So for relative polar coordinates, we precede the distance with at, similar with the relative coordinate, and then use the angle bracket. Okay, so find the angle bracket on your keyboards, the one with lesser than symbol, and then that's the one we use to indicate the angle for the line. So for polar value or polar coordinates, we type at, distance, and then angle bracket, and then type the angle. Example, at 5 units, angle 45 degrees. So let's try to do this. Okay, so let's invoke another line. So L, enter. So click anywhere for the first point, and then for the second point, let's type at, and then 5, and then angle bracket, and then 45, then escape, and then zoom in. That's our line created using the relative polar coordinate. Okay, so we use the relative polar coordinate to plot our lot plans. So with this lot description, we are now ready to plot the lot. So let's just select everything and then erase. Enter. So let's try now to plot our lot plan. But before we invoke AutoCAD to do the line command, let's write first what shall be our relative polar value entries. So for the next point or two, okay, the first point will always be absolute, so that will be either 0 0 or anywhere on your drawing area. But the best starting point for any drawing shall be from point 0 0, because it will make your life easier when you transition to other softwares. Okay, for example, you transpose or you import your 2D drawings to 3D or to SketchUp, it will always be at the origin. Okay, so it's important that we shall start from the 0 0. So point 1 shall be from 0 0. Point 2 we shall type at, and then so this is in meters, we shall use millimeters. Okay, so 7,890 millimeters. Angle, and then south 28 degrees. We type D in place of the degree symbol. So south, so S 28, D for degrees, and then 50 minutes east. So this shall be the value entry for our second point. For the third point, again at distance of 5,970 with an angle of south 61 degrees. Then I typed this wrong. Okay, this must be in minutes, not seconds. So 10 minutes. Okay, and then west, and then it's similar to the other points. So at 4,000 angle south 87 degrees 15 minutes west, and then next again at so those are the polar coordinate values that we shall input for point 2, 3, 4, 5, 6, and 7. So let's invoke AutoCAD to do the line command. So L, enter. Again, for our first point, since this is our initial drawing, so 0, 0 to start the drawing at the origin. Okay, so enter. And for the second point, let's just input these values, okay, sequentially. So second point, so at 7,890, angle south 28 degrees 50 minutes east, then enter. So you can zoom out or you could escape so that you could see the extent of the drawing. Escape. So this is line 1 to 2, and let's continue. Position your geometry so that you could snap to the endpoint of line 1 2. So line again, enter. Then first point, let's just click or snap to point 2. Okay, we know that point 1 is from the origin, therefore this is point 2. So we snap at the end point, which is point 2. Okay, so for the third point, this shall be our value entry. So we type at 5,970, angle south 61 degrees 10 minutes west, enter. So we could see now it's already starting to form. So for the fourth point, at 4,000, angle south 87 degrees 15 minutes west, then enter. And then for 1 2 3 4, for the fifth point at 13,730, angle north, this time north 66 degrees. That this must be 41 minutes. Okay, this is a mistake. So north 66 degrees 41 minutes. Okay, so N 66, D 41 minutes, and then west. Enter. And then for the 6 point at 4,000 angle north again 15 degrees 16 minutes to the west. Enter. And then at for the last point 11,800 angle north 36 degrees 8 minutes to the east. Enter. Oh, we missed line 7 to 1. Okay, so for the meantime, let's just click to the origin to snap. Okay, so snap to the origin, so click and then escape to complete the object. Okay, and let's correct that later on for the succeeding plates.